Hi, I'm Dr. Michelle Staben-Wabker, and I'm here to tell you some about various demonstrations you can do regarding particle technology with stuff you can find around the house. And this is really relevant to the types of problems that we actually see in our daily work at GlaxoSmithKline. What we do in that department involves particle technology. We have to see how different powders and granules will flow together to make some sort of medicine. This is just your regular old tap water where we've put in some blue food coloring, because everybody thinks of water as blue, so that we can see it on the powders we're going to put it in. Over here what we have is isopropyl alcohol, and what we've done is we've added this red food coloring to this isopropyl alcohol so that again we can visualize what it looks like when we're putting it on the powders. So what we're looking at here are the wetting behaviors of different dry powders, basically how different liquids will actually contact the different powders. So the first one here is a really coarse sugar, and you can see that the liquid drops in pretty quickly. It's pretty quickly absorbed by that. The next thing is standard table sugar, and you can see that it takes a little bit longer for it to be absorbed than it does in the more coarse sugar. And finally we're looking at powdered sugar, so your confectioner sugar. And as you can see, it's going to take much longer because these are much smaller particles. There's less space between them for the liquid to get in there. In this case, what we're going to be looking at is squeezing honey onto the different sugar crystals. So you can see how viscosity, which is the resistance of fluid to flow, affects how stuff falls in. So as you can see, it's taking a lot longer for the honey to soak down into the sugar crystals because it's a much thicker fluid. These effects are going to be even more pronounced as you get down to the table sugar, and then it'll be really obvious when you look at the powdered sugar that it's going to take a really long time for the honey to sink down in because it's so thick and there's really no space between those tiny particles for it to fit. That is so cool looking. So what we're looking at here is we have breadcrumbs and just ground black pepper in containers, and what we're interested in seeing is how the different surface tension, so what kind of holds drops in a drop shape, how a difference in surface tension affects how these liquids are going to wet the powders. So this first blue liquid is water, and as you can see with these breadcrumbs here, you basically form a drop with it. We'll also look at how it is dropped onto the pepper. And again, it's hard to see, but basically they're forming balls of water with the pepper around the outside of the water ball. Now, if we move on to looking at a rubbing alcohol with food coloring in it, it actually soaks in. And that's because it has less surface tension. So that's why it's able to break through the layer of breadcrumbs and soak into the material. And the same thing we'll see with the pepper. So again, we're not forming these balls like we were with the pepper and the water because this lower surface tension means a lower contact angle, so it wets the material better.